In this problem, we will be simplifying a complex rational expression. A complex rational expression is just a really complicated way of saying fractions inside of fractions. So in this case, here we have four small fractions inside of one larger fraction. And the way to take care of a problem like this is to first find the least common denominator of all of the inner fractions. So we're going to start by making a list for our LCD. We want to make sure that every single denominator is factored, and in this case x minus 2, x plus 2, x plus 2, and x minus 2 are all completely factored, so we can start using them for our LCD, or again, least common denominator. So we'll start with our first factor, x minus 2, and then we'll check if any of the other fractions have something that we don't already have. So this second fraction has an x plus 2 that's different than x minus 2, so we're going to multiply it inside of our LCD. Our third fraction has an x plus 2. We already have one of those in our LCD. We don't need a second one. And now an x minus 2. And again, we already have an x minus 2. So we have our completed LCD. With this LCD, we are going to multiply it to every term in this fraction. In other words, we're going to take it and multiply it to the numerator and denominator. When we multiply it to the numerator and the denominator, we will not change the original problem, because if you multiply it to the top and bottom of your fraction, it's as if you multiplied by 1. So we'll end up distributing this to each of our terms. And when we do, we're going to get something that looks like this. And I'm going to write it out fully to avoid any confusion. We have x minus 2 times x plus 2, the term being distributed, times our first fraction, x plus 2 over x minus 2, minus our second fraction, x minus 2 over x plus 2, times x minus 2 times x plus 2. All over, and now this will be our denominator. We have x plus 2 times x minus 2. Again, the term being distributed, the order doesn't matter, times x minus 2 over x plus 2 plus x plus 2 over x minus 2 times x plus 2 times x minus 2. This might look very intimidating, but just realize it's for the sake of space that I had to rewrite it like this. Typically, you could just go to the beginning of your problem and write this x minus 2 times x plus 2 next to each term, and it will mean the same thing as all this work we've done here. Now from here, notice we are now multiplying two fractions together in each of these cases. This one may not look like a fraction, but technically we can put every single one of these over 1, and it's the same thing. And when we do that, we now have factors that will cancel out. We have an x minus 2 in the bottom that'll cancel with this x minus 2 in the top of this fraction. This goes back to multiplying rational expressions, as covered earlier in this section. And now x plus 2 we can cancel from the top and bottom of this pair of fractions. And again, x plus 2 will cancel here, and x minus 2 will cancel here, leaving us with x plus 2 times x plus 2 minus x minus 2 times x minus 2. That minus that we had up here that was on the outside of our fraction has to be put on the outside of parentheses because it's being multiplied to the entire x minus 2. And that's all over x minus 2 times x minus 2 plus x plus 2 times x plus 2. And now from here, we're going to multiply all of these out and start canceling our common terms. So here we're going to distribute this x and then distribute the 2, which gives us x squared plus 2x plus 2x plus 4. Then we'll get a minus the quantity of, because this minus is going to be to every term here, and we're going to distribute these as well. So minus x squared minus 2x minus 2x plus 4. And this is all over the same two pairs of multiples being added together instead. So we know this x minus 2 times x minus 2 will again be x squared minus 2x minus 2x plus 4. And now we're going to have plus the quantity of x squared plus 2x plus 2x plus 4. And now from here, we're going to combine our like terms together, which I'm going to start over here. So in the top, we have to first distribute this negative before we can combine our like terms. And whenever you distribute a negative, that just means you're going to make this a positive and change every sign in your parentheses. So we'll get a negative, a positive, and a negative. So that means our x squareds will cancel out. X squared minus x squared is 0. We then have 2x plus 2x plus 2x plus 2x is 8x. And then 4 plus negative 4 is 0. So our numerator is just 8x, and our denominator, we can now combine these like terms. We have x squared plus x squared is 2x squared. Negative 2x minus 2x plus 2x plus 2x. So combining all of these terms together will give us just 0. They'll all cancel out. And then we have a plus 4 gives us plus 8. And now finally, the last thing that we can do here is factor out a 2 from the denominator, which gives us 8x over 2 times x squared plus 4. And with this, we can cancel a common 2 from the top and bottom, leaving us with 4x in the top. So we end up with 4x over x squared plus 4. And that is the simplified form of the complex rational expression that we started with.